Hi, I'm David Moon, and this paper, Sets Characterized by Missing Sums and Differences in Dilating Polytopes, is joint work with Thao, Archit Kulkarni, Stephen Miller, Jake Wellens, and James Wilcox. A finite set A of integers is called sum-dominant if the cardinality of its sum set A plus A is greater than that of its difference set A minus A. As a typical pair of elements contributes one sum and two differences, we expect sum-dominant sets to be rare in some sense. In 2006, however, Martin and O'Brien showed that the proportion of sum-dominant subsets of the integers from 0 to n is bounded below as n grows by a fixed positive constant. Hegarty then extended their work and showed that for any prescribed non-negative integers s and d, the proportion rho sub n sd of subsets of 0 to n that are missing exactly s sums in the sumset range 0 to 2n and missing exactly 2d differences in the difference set range minus n to n, that this proportion also remains bounded below in the limit by a fixed positive constant. We begin to consider the following question. Are such sets, characterized by their sums and differences, similarly ubiquitous in other spaces? We generalize the integers in a growing interval to the lattice points in a dilating polytope. Here, we let np denote the n-factor dilation of p, and L of np the set of lattice points covered by np. In this paper, we focus primarily upon the higher dimensional analog of Hegarty's proportion rho sub n sd, in which sets are characterized by their missing sums and differences. Within this generalized context, we let rho sub n sd denote the proportion of subsets of L of np that are missing exactly s sums in the sumset range L of np plus L of np and exactly 2d differences in the difference set range L of np minus L of np. As it turns out, the geometry of the core polytope P has a significant effect on the limiting behavior of our proportion. We define a geometric characteristic of polytopes called local point symmetry, and show that rho sub n sd is bounded below in the limit by a fixed positive constant if and only if P is locally point symmetric. We further show that the proportion of subsets in L of np that are missing exactly s sums and at least 2d differences remains bounded below in the limit by a fixed positive constant independent of the geometry of P. A direct corollary of the first theorem is that if P is additionally point symmetric, the proportion of some dominant subsets of L of np also remains positive in the limit, thus providing a generalization of Martin and O'Brien's original result as well. Thanks for listening.